Okay, everybody, it looks like we're at the top of the hour. So let's get started with this session on soft skills. Thanks for being here. We have a total of 5 presentations here. I'm not currently seeing a presenter for the paper on Can You Help Me? Is that correct? I'm pretty sure. I'm looking at it. I don't see anyone. So if someone shows up for that presentation, I guess we'll add them in as it goes. Yeah, we'll have 5-minute presentations and then an open discussion. So let's start with Monisha Pullimwood and Margaret Leahy from College of New Jersey. Is that correct?
Sure. But I thought there was another one before us. Can pre-class GitHub contributions predict? Oh, they're not there either?
I'm here.
I'm seeing, let's see, well, in my list, at least, I guess it was the paper on Can You Help Me was the first one.
We're fine starting
Yeah.
now.
I'm fine, Wow.
Whatever, it's 5 minutes.
Yeah.
Very good, thanks.
Let me just share my screen. Okay. So, hello everybody. I'm Monisha Pullimwood.
Good afternoon, I'm Maggie Leger, and today we're presenting our experience report, a project-based collaboration between software engineering and criminology students, building applications to understand racial injustice in the criminal justice system.
So we'd like to first set some context. The College of New Jersey, where the two of us work, is a public, primarily undergraduate and comprehensive institution where faculty are teacher scholars who share a commitment to liberal learning.
Within the liberal learning and the comprehensive education at TCNJ, courses outside the computer science discipline are often perceived by software engineering students to be unconnected to their major. At the same time, students from non-STEM majors often perceive STEM courses to be too demanding or technical.
So to try and address these concerns, we have a grant from the National Science Foundation to study the efficacy of the collaborating across boundaries curricular model. In this pedagogical model, students in 2 courses from 2 disciplines collaborate with each other and a community partner on a STEM-focused project to address a community-identified issue. The intent is that students from both courses with diverse perspectives and disciplinary backgrounds will not only learn the STEM concepts more deeply, but will also learn how to collaborate and integrate concepts from their respective fields to develop scientific solutions for complex real-world problems.
And that brings us to the collaboration that we'll be talking about today. So the murder of George Floyd and the racial reckoning that followed in summer 2020 deepened our respective commitments to making racial justice a focal point of our respective classes in the fall 2020 semester. Embracing the benefits of interdisciplinary project-based learning, we designed a collaboration between our classes and the local chapter of the Campaign to End the New Jim Crow, a community organization dedicated to ending racial injustice in the criminal justice system.
So in our paper, we reported on our experience as we and our students grappled with issues of racial injustice in the criminal justice system and taught emphasize interdisciplinary collaboration with a community partner. So from the software engineering perspective, I really wanted my students to thoughtfully examine the social impacts of the applications they build that inscribe and reinforce rational discrimination.
And for my students in our penology course, I wanted to provide them with the opportunity to explore how computational thinking could be employed to address criminal justice reform.
And to ensure that students from both disciplines had a common foundation, Maggie facilitated a lecture discussion on the history of racism in the United States prison system. They were also pointed to additional resources for further exploration. And students developed applications that addressed a variety of areas that they had been learning about and that were highlighted by our community partner. These are just some screenshots of, the applications that they developed in the class.
And so, in terms of student learning outcomes, students reported significant increases in their learning in the areas of scientific skills, computational thinking, and civic efficacy. Participation was additionally associated with an improvement in scientific literacy of the non-STEM majors. And overall, this was correlated with an increase in perceived responsibility to help others for penology students, an increase in perceived capacity to address social problems among the software engineering students.
And this spring, we just completed a second CAP collaboration in our software engineering and penology courses. We implemented the lessons learned from our first collaboration, but this time in an in-person mode with the same learning goals.
And so within this collaboration, the findings pertaining to student learning outcomes have wider implications beyond a particular project or course. Students grew in their perceptions of responsibility to address social issues and their confidence that their education has imbued them with their skills and knowledge to affect change. Responsibility and efficacy are necessary building blocks to address societal problems such as systemic bias. So while we encountered challenges, this experience reinforced to us and our students the value of interdisciplinary teamwork and collaboration with a community partner.
Thank you for listening to the overview of our course collaboration. We invite you to read our paper for more details and look forward to your questions and comments. You can find out more about the CAB model and the collaboration supported at the links on this slide. Thank you.
Thank you.
Super, thanks very much. Let's see. Next up, we have Jolene Cui from North Carolina State.
Okay. Can you see my screen now?
Yes.
I'm gonna start. Hi everyone. My name is Jolene Cui. Today my topic is can pre-class GitHub contribution predict success by student teams? Two research questions are studied in our paper. Question 1 is the success of student teams better predicted by the maximum contribution of any team member or by the average contribution of all team members? Question 2 is which pre-class GitHub contribution lead to the success of student team projects? Here are some necessary backgrounds. Our data source is a software engineering class that has been taught at North Carolina State University for over 15 years. This class focused on object-oriented design and development. There are two major projects in this class that students work inside 304 teams. Project topics including refactoring, writing tests, and fixing sets of related bugs in the current code base, add features to the current system, or update large pieces of functionality. We collected all project submissions from 2011 to 2021 and manually located all the students' GitHub accounts. Overall, we successfully retrieved 1,081 GitHub accounts from 1,253 students who have taken this class from 2011 to 2021. Here's a table shows the retrieval rate of every semester since fall 2011. We can observe a better and a more stable retrieval rate start from 2016. Our final dataset only includes the semesters start from spring 2016. From each GitHub account, we collected all user contribution metrics. This table shows all the metrics we logged from GitHub. We don't have enough time to go through this here. Simply speaking, we include all the contribution metrics that GitHub can provide for a single user. But we further searched the school calendar from 2011 to 2021 to retrieve the exact date of semester start and end for every semester so that we can divide our student data into three groups, namely the before, during, and after the class. In this class, only the before side is used in the analysis. We took the average of each GitHub contribution metric we collected across all team members to model the average technical ability of a team. We also took the maximum of each GitHub contribution metrics across all team members to model the maximum of the technical ability of a team. We then divide all the 421 teams into 3 groups based on the grade they received for their projects. The top group contains the top 1/3, the middle group contains the medium 1/3, and the bottom group contains the bottom 1/3. We constructed a 6 binary logistic regression model to classify the top and middle, the middle and bottom, and the top and the bottom. We can see that using the maximum to model a team works slightly better when we try to predict whether a team falls in the top or the middle tier. We got a 60% accuracy over 59% accuracy. However, when we try to predict the top and the bottom, and the middle and bottom, the average works better. The answer to research question 1 is actually it depends. When we try to distinguish the top team from the middle team, the maximum actually perform better. When we try to distinguish the middle team from the bottom team and the top team from the bottom team, the average gives us a better prediction power. We believe that the contribution of this, the combination of these two can help instructors better understand the team dynamics of student teams. The answer to research question 2 is very complicated. We list all the statistically significant features that distinguish each level of teams here. For the discussion of each of these features, please see our paper. The implications from a student perspective are, if a student team wants to improve from a lower tier to a higher tier, they should first try to make more commits on GitHub to improve their general technical ability. The second, fork more repositories related to full stack development and get hands-on experience in full stack development projects. The third, make the contribution to a broader range of open source software projects on GitHub. The implication from an educator perspective is that we highly doubt about the team formation techniques that do not consider student background. We appeal to educators to think about the team formation process seriously. How to make the team formation as fair as possible with team of even strength from a GitHub perspective. In summary, the main contribution of our research are, first, we mined a novel and relatively large dataset on students in software engineering. The second, we discuss student software engineering team modeling with GitHub metrics. And last, we give suggestions for both students and editors. This concludes my talk.
Super. Thank you, Shenlin. Let's see. Next up, we have Emily Lau Christensen from IT University of Copenhagen.
Yep. Share my screen here.
Mm-hmm.
Yeah, so I'm Emily Christensen from IT University in Copenhagen, and this paper is a joint work with Maria Pasvaria from Lund University in Finland. So in this study, we present our experiences and results on an online Scrum simulation for distributed teams that was created in a multiplayer game, Don't Starve Together. The way software companies work has recently been reshaped, so it seems clear that distributed software development is here to stay, and we need to be able to train our students to use both Agile and Scrum in distributed settings. The simulation was designed and created in February 2020, and in this study, we share our findings on how the simulation works and what the student learning outcomes are. So Don't Starve Together is a wilderness survival game. Players need to explore an unknown world, use the affordances that are provided, and try to avoid death. And staying alive in Don't Starve Together requires constant and careful maintenance, and there are no tutorials or rules or points or specific objectives in this game. So while most virtual game worlds are designed to support a very particular type of game, sandbox games where players, they can roam freely, they can be described as digital playgrounds. And Don't Starve Together is an ideal digital playground for a Scrum simulation because it's an environmentally realistic open world sandbox game. The main goal of the Scrum simulation is to provide a digital play space where participants, they can learn Scrum in practice, while at the same time providing an opportunity for team building. So the Scrum teams, they need to plan and complete a mini Scrum project and keep track of their progress. And our research questions for this study are: what were the main learning outcomes of the Don't Starve Together Scrum simulation as reported by the students? What were the experiences and perceptions of the participants on the Scrum simulation? And how could the simulation be further improved to enhance learning opportunities? So in this study, we applied the method critical making, and that combines both critical thinking with iterative goal-based material work. And the 3 stages of this method were carried out over the duration of a year. We ran the simulation 25 times in total with 244 participants, which included both students from 8 different universities and industry product owners and agile coaches. And we analyzed 196 student learning diaries and 84 student survey responses, and also held a retrospective meeting with 9 of the product owners and 10 of the agile coaches who participated in the simulation to collect feedback. The main learning outcomes as reported in the student learning diaries were communication, estimation, Scrum in practice, communication and collaboration with the product owner specifically, and Scrum events. The survey responses were primarily positive, and they indicate that a majority of the students learned how to use or apply Agile and Scrum topics in practice, explain what the topics were due to the simulation, or heard about the topics during the simulation. So in summary, in this study, we presented a digital playful simulation for teaching Agile and Scrum that can be used in distributed online settings. The Don't Starve Together Scrum simulation. None of the previously reported games for teaching Agile and Scrum were designed for distributed online settings. So this presented simulation, it's a unique tool for online teaching. And in addition, the inclusion of the industry product owners in 2 of the courses provided an opportunity for team building within the Scrum teams. And many of the students reported that the experience would help improve their collaboration and the overall success of their team projects. So the results of this work show how the Don't Starve Together Scrum simulation can provide learning opportunities for students and an enjoyable digital playable experience for all participants. Thank you.
Super, thanks, Emily. I've noticed that Michaela has joined us. Michaela, I think we'll leave your presentation to the end. Thanks for being here. But although actually, okay, while you're there, can check your audio, just make sure I can hear you okay.
Can you hear me now?
Yes. Okay, great. Sounds good. I'll let you get situated. And in the meantime, we'll hear from Chris Bond from University of Nebraska at Lincoln.
All right, so thanks. Sorry, just getting my own timer started. I run the capstone program for our School of Computing's capstone for the School of Computing. I run the capstone program. There we go. Sorry, off to a bad start. This particular experience that we had dealt with our software engineering majors, and one particular aspect of it that plays into it is that our software engineering majors have 2 years of capstone instead of just 1. In their first year of capstone, they have a typical senior design project. It's a 2-semester project, half a dozen students. There's an external sponsor, typically from industry, might be from some other part of the university, but regardless, the sponsor is someone other than the faculty supervisor. And we provide a lot of support for the senior design teams. Obviously, the faculty supervisor who provides guidance, just-in-time instruction, grading. I also have some PMP project managers on my staff, and they provide a lot of feedback and guidance to the teams as well. And then, of course, the sponsor has the vision and is responsible for establishing that what the students are working on is actually going to be valuable, actually is going to make a difference. And then we also bring in some volunteer coaches from industry who typically provide guidance on some technical issues. They also sometimes provide guidance on people skills. Well, as it turns out, when we decided to do this little experiment, we couldn't provide that much support, and as for reasons I'll get to into a moment. But the teams that did this already had a year of capstone under their belt. They'd already hit all the check marks that we have to do for various agencies that want us to have a capstone. So it gave us a little bit of flexibility to be able to try something different in their second year. They wanted to try to do a startup model. But as I said, we could not provide as much support for them through the university. And so we offset that by bringing in some very specific coaches from industry. So the students had already worked closely together for a few years. We have a cohort model. So these students already knew each other very well. They already got past all that forming and norming part of team development. As part of the core software engineering sequence, they'd already spent a semester working on an open source project. This particular cohort had worked on OpenMRS. And as I said, they also had already completed a year of senior design. So we were pretty close to the limit of what we could teach them on the technical side of things. And so this was going to be an opportunity to learn some of the other aspects of what it takes to start up a new company that does software development. We didn't want to just throw them to the wolves and let them figure it out. We wanted actually to be able to guide them through the process without jeopardizing their IP ownership. So our university's bylaws, in a nutshell, part of it, the relevant part says that students own their intellectual property. The work they do is theirs, unless it's commercializable and makes significant use of university resources. Well, obviously, the intent was to make this commercializable, so we had to be careful about making sure they weren't making significant use of university resources. And so we were able to overcome that problem by bringing in an industry partner. So Don't Panic Labs, we already had a good relationship with them through for other reasons. And part of what they do is they provide training for startup companies to help them get through the market analysis and product development to make sure to give these startup companies the best opportunity for success. And they volunteer to provide the same training for free to this group of students. So in the first year that we did this, we got them off to a bit of a slow start. That was unfortunate, but I'm sure you all remember fall 2020. So they got off to a bit of a slow start, and then they had several do-overs as they were going through and refining their product ideas, because that's what the point of market analysis and product discovery is finding that right product. So they actually got started on software development a bit late, but they eventually were able to get to a beta release. So we learned some valuable lessons from that, and we actually tried this again this last year. It's not in the paper. But we got them started much sooner. I mean, we had them meeting with the folks from Don't Panic Labs in that first week of the semester. And so they were able to get through the product discovery much faster. I think they may have fudged it a little bit, but after I talked to them, they said that, even though they kind of already knew what they wanted to do, they were able to get off on the right direction, were able to refine their ideas. So the key things from this was they were able to learn that business side and what it takes to make sure that what's being developed actually has an interest in the market. So there's some key things that you need to be wary of if you want to duplicate this. I'd be glad to tell you about them on your own, but I'm already over my 5 minutes. So thanks.
Super, thanks, Chris. Okay, and now we have Michaela from Clemson University.
I was sharing my screen. Okay. Can you all see my slides?
Yes.
All right, awesome. So sorry I'm late. Hello and welcome to our talk about our paper titled, Can You Help Me? An Experience Report of Teamwork in a Game Coding Camp for Autistic High School Students. My name is Michaela, and I will be presenting our work today. So here are some motivational statistics about coding camps, which kind of inspired us to start and continue our camp for the second year. So coding camps are great at fostering interest in programming and development jobs. In our research before we started our camp, we've only found one coding camp that targeted the autistic student population. And then coding camps like ours teach necessary teamwork skills for future industry positions. So this year's camp was our second annual summer camp for autistic high school students. We spent 2 weeks teaching students video game programming and design using an open source professional game engine. We also spent these 2 weeks working on skills such as communication and collaboration. And this was just a quick overview of our camp. If you would like more information on how our camp was run and what we did each day, please refer to our paper, because now I'm going to transition into our lessons learned and our recommendations from running our second annual summer game coding camp. So throughout the camp, we had to adapt to different things that popped up. First, we found that students were easily distracted by other students talking in and outside of the Zoom chat. We had students who would randomly blurt out space facts, which then started an entire avalanche within the Zoom chat about space. So to reduce that distraction, we encourage students to use a provided Google Doc to write their off-topic discussions in. This greatly reduced these off-topic comments within the chat and just being blurted out, and improved student focus during instruction. And then during each break period we reminded students that they could talk about these topics that they wanted to talk about during the break, so it wouldn't interrupt anything important. And so our recommendation is to provide a shared document for students to write their off-topic thoughts into, and then remind them later about these topics to talk about them at more appropriate times. Next, we found that students would bully one another within the Zoom chat. To mitigate this, we held an open forum with the students to discuss kindness and create guidelines for the camp. We asked the students for their input and facilitated a discussion around kindness in the classroom. And we created 4 different guidelines that we continually reminded students about throughout the remainder of the camp. So our recommendation for this is to have a discussion with your students about kindness and create guidelines based on that discussion. Next, autistic students, if overwhelmed, are likely to fall behind on instructions. So before our camp began, to kind of mitigate this before it started, we provided written instructions for each day of camp with images as shown in like this image on the right. So we had detailed instructions with images to walk through that day's material. Additionally, the instructors found these instructions to be super helpful in walking students through them during breakout room help sessions. So our recommendation is to provide scaffolded instructions to students so they can catch up at their own pace if they get lost on a specific topic. Additional challenges we faced included that we found our material took 2 to 3 times longer to cover than we had originally planned for. So during our camp, the instructors held preparation debrief sessions to determine, what needed to happen the next day. So we determined what needed to be taught and what we could skip, and then we modified our original instructions to better fit our timeline where we were at. So for this reason, we recommend having backup lectures prepared to reduce instructor stress around creating new lesson plans for each camp day. Lastly, in addition to changing lesson plans, we also had a narrow scope on what kinds of games students would want when planning our camp originally. So during the second week of camp, we surveyed all the students what their favorite game mechanic was going to be, and then we taught that mechanic so they would have something to build on for their final project. That's okay. And I just want to say thank you and sorry that I'm late, and I appreciate you all listening to my presentation.
Thanks, Michaela, and no worries at all. We're right on time. Good. Let's thank you for all the presenters. Great talks. And let's open up for questions from the audience. If you are a chatter, you're certainly welcome to put something in the chat, or else speak up.
Well, I suppose I could go and ask a question. So this is for the first talk. So I'm intrigued with the project you did between the 2 departments, in no small part because we also just within our capstone, we've just recently tried an interdepartmental capstone project. And I think the polite way to put our experience would be, we learned some lessons. So I was wondering if you could share some thoughts on how you're able to get to a common understanding between the two students in the two majors as far as how the project was going to go forward.
Yeah, that's a great question. So I've been collaborating with other disciplines for this class for the past few years. And so each semester I learn something more and I tweak it, and that has been helpful. And certainly even when Maggie and I collaborated in fall 2020, we had lessons to learn that we then tried to apply those lessons for this spring semester's collaboration. That said, one thing that we have found very helpful is to have very clear outline for how the project is going to go. Not the project ideas themselves, but sort of a timeline, deadlines, what each so we had teams that had students from both the classes. And so we tried to be clear about what each class, the students from each class would bring to each deliverable to avoid some of the confusion that might occur. We certainly had to keep talking to students about what the other discipline is bringing to the project and how each discipline is contributing to the project. Maggie, maybe you can say something from the perspective of your students, because that's where we found some of the concerns.
Right. Thank you. Yeah, and I really give Monisha. So Monisha is one of the PIs for the NSF project, and she's been doing these types of collaborations far longer than I have, and so I've really leaned on her and her expertise and experience. And so, like, having that clearly delineated division of responsibilities was very helpful. So in the document, there was lists of, this is when the penology students are going to take the lead on supplying content related to the different applications. And so for the collaboration that we're talking about here with the Campaign to End the New Jim Crow as our community partner, our students in my class were responsible for finding the content related to the different topics. So looking at felony disenfranchisement or bail reform, and then that would provide the context or the foundation for the computer application. And so students in penology, I would say overall, are probably not as don't have the experience, of course, with the computer programming side as the software engineering students do. And so sometimes there was a bit of tension in terms of not necessarily completely understanding what was happening on that other side, or the ways in which my students were able to contribute. And so I think Monisha did a great job of providing suggestions for how my students, as educated but non-technical participants, would be able to provide some help, such as going through and reading through any types of instructions or guidelines. And so that was another way in which my students were able to contribute to the project. But I would say it took a lot of planning and preparation, and then still just trying to learn some lessons and implement them the next time.
I think it also helps for the students to have a common understanding of what the theme of the project is. So in this case, racial injustice in the criminal justice system. My students knew nothing or very little about that topic, even those who consider themselves to be well educated on the social issues. And so having Maggie give that introductory lecture and all the resources, and then gaining an understanding from the penology students as well.
Super, thank you.
Thank you.
Yeah. Chris, there's a question for you now from Trenton, asking about the sort of student sponsors being flaky or busy, and that getting in the way of them contributing in that role to the projects. Do you see the question in the chat?
Yeah, just parsing through it now.
Yeah.
Okay. Yeah, so just to repeat it, because I don't know if it's going to be captured in the recording, the question is that as a student, they sponsored a senior project. He was a club president, wanted a custom Mechie device. As the client, he found that he was often busy and didn't pay as much attention as he would have liked? Are there any issues with student sponsors being flaky or busy getting in the way of projects? Certainly that is cause for concern, and that was not a problem these 2 years that we tried, partially because we were a bit selective. So we actually have several, I guess maybe 36 or so software engineering majors who went into their second year of the Capstone program. Of those, only 6, well, the first year 9, but all 6 this last year went on to do the entrepreneurial thing. The others did something else. Most of them worked on another senior design project in their second year in a different capacity. So that the flakier students, if you will, go into what we call a process specialist role, which is just a polite way of telling them you need to work on development a little bit more. Those that are stronger go on to some other roles where we already know that they're not going to flake and cause problems for students. And then these entrepreneurial teams, none of them were of the flaky sort. Otherwise, we would have said, no, you can't be on this team.
Super, thank you. I have a question for Michaela. There's the old. This is an old line that accessible design is simply good design. And so, in the spirit of that statement, I'm wondering whether, to what degree, the things that you did in this course where you had autistic students in mind in particular would simply be good ideas for kind of project-based courses in general.
Yeah. So we had videos and we did live lectures and we had these scaffolded instructions. I think all of those would be useful for a class and be part of universal design things. Sorry, I can hear myself and it's very awkward. But yeah, I think that answers the question.
Okay. Mm-hmm. Yeah, good. No, it struck me that a lot of things you were talking about, I thought, boy, I would like those in my class too. And really, really good ideas. So, yeah. Nice. Let's see. We have a question from Monisha for Emily, asking about the backgrounds of the students that participated in the simulation. Were they students from different disciplines? How did you manage respect among team members?
Yeah. So a majority of the students were taking courses or programs in software engineering. There were a few of the students, however, from the 2 groups, I think it was in Finland, that were not from technical backgrounds at all. So there were a few that had like mixed backgrounds, but most of them were within software engineering, programming, math, those kind of things. And how did we manage respect among team members? We didn't actually manage very much in that regard. The students were very self-organized in their preparation. All of the teams were given a few materials, the slides and the handouts they could prepare beforehand, and it was up to them to decide how they wanted to handle the situation or handle the simulation itself. They had time to practice if they wanted to do that beforehand, but they could also just jump in without any preparation. And so that varied a bit from team to team, how much they had discussed beforehand what they were going to do.
Mm-hmm. Super, thanks.
I do have a question for Nicola as well. I was curious about the age of the students. Were they very similar in ages, or was there a bit of a difference there?
Michaela, did you hear the question?
Oh, I'm sorry. So we had high school students. I think the youngest was 14 and the oldest was 18. Did that answer the question?
Yes.
Yeah. Okay.
Yeah, so a bit of a range. And also, how about the gender?
So last year they were all male. The first year, which I'm not presenting on, there was a mix.
Thank you.
Mhm. Great. Another question from Michaela, from Manisha. Did you run these camps in person? And are some of the virtual distractions similar or different from what you would find in in-person mode?
So our first camp was 100% virtual. The second camp was hybrid, but all instruction was online, so everybody was on a Zoom call together. So I would just call that virtual because all the instructors were online. So we never really did an in-person camp 100%. So these distractions. I would say the in-person students were distracted by themselves because they were all in one room together, talking all amongst each other and everything. So it's similar to regular classes.
Great, thank you. I have a question for Jalin. You noted at the end of your presentation, kind of suggestions for students who weren't doing as well in the project-based courses. So how to improve, and so you suggested to do better, do more commits. And I'm wondering about the I was kind of wondering about that a little, whether it's a sort of a symptom, if you will, of good behavior, but is that is it, and if not, if it's not, sort of simply do more commits, then what is it? What would you sort of suggest, or what did your results kind of suggest as sort of good behavior?
So I think the first difference is that the commits that I'm analysis in my study is actually the pre-class commits. I analyze their data from their personal GitHub accounts, so that I sort of gathered how many commits you have already done before you take this class. So the analysis show that if for example 3 students form a team and they have an average commit number that is higher, that's more likely their team will perform better in the class team projects. So yeah, I definitely suggest students to write more code, and basically I think everybody kind of believe that if you have already written more code, you have a higher technical ability and you have a tendency to perform better in the class. But my emphasis will be, if an educator or instructor know this already, they should take this into consideration when they form student teams. Otherwise, you pretty much just already decide how much this team can do by just the formation of the team. For example, your top 3 students form a team, the bottom 3 students form a team. It already, like, you can pretty much decide, like, know what they're gonna get at the end of the class. So I'm kind of try to I'm kind of want to the educator to keep this in mind and try to even that out, so that you have an average student team have a fair start at the beginning of the class. I have seen some of the research, they sort of use the in-class commit to predict the project result during the class, but I don't think that is earlier enough. So basically, you have already formed the team. The student already take the class for half of the semester. Then you give them suggestion or prediction. I think that's too late. I'm kind of wanna, at the beginning of the class, when you just form the team, I can identify which team probably will have problem. At that point, no matter which way you want to go, you probably want to focus more on this team, or you probably want them to like rearrange the member of the team. Which way you try to go is decided by the instructor, but I want to give them an early prediction on that.
Okay, very good. Thanks. There's actually a follow-up in the question in the chat from Monisha. Are GitHub commits then a proxy for development experience in your?
In my study, I actually take all the GitHub metrics into consideration, like how many repos the user have, or even the size of their repo. So my current model is relatively simple. I'd probably going to try to use more complicated model in the future. I'd say that I try to proxy their technical ability based on their GitHub contribution, all kinds of contribution, like how many pull requests you have made, and how many comments you have made on GitHub. I think those contributions are all reflect of like different perspective of the technical ability.
Great, thank you. Other questions from the audience?
I had a question for Christopher, please. So Christopher, in your presentation, you had mentioned that the students retain the intellectual property unless there were significant resources, the college had invested significant resources. How is that defined? Is that something that's clearly articulated somewhere? And then who makes that determination? Yeah, I'm just curious as a non-software engineer, how that would be defined and who would make those decisions.
It is not clearly defined at all. I mean, I think we can appreciate that the real intent is is work that's done from funded research, but that's not the way it's written, and well, we have to work with the way it's written. So I actually talked to the university's general counsel and described the level of support we were planning to provide, and they said yes, that's fine. But we're already starting to see some of the limits. For example, the university has an office that is geared specifically toward turning university work into a commercializable product. That was clearly off limits. We asked the question anyway, but yeah, it was off limits. And then, we tried to, we since we were able to find resources for almost everything else. For example, the students in the local law school offer a clinic to help things like, what does it take to start up an LLC? And so we were able to steer them in that direction instead of through university-funded sources.
Thanks.
Thank you.
Mm-hmm.
If I could ask a follow-up question to that then. So a couple of questions. One is, how do you create and sustain those relationships with the industry partners who come in and volunteer their time and support the students?
Well, the kind of the creation of it is it's a lot of these relationships start because we're trying to get industry partners to sponsor projects, and often the answer is, well, we can't do it this year, but maybe in the future. And so then our immediate follow-up question is, oh, well, would you be able to provide at least some time, a couple hours a week as a coach? And so that that kind of just starts the process. Then something we also started doing that last summer is we started hitting some of the local practitioner-focused conferences to get to kind of sniff out potential coaches. And there's a very low success rate based on the number of people we contact through those conferences, but we find a few, and then it's just a matter of showing our appreciation. So for example, this year we gave little tokens of appreciation for the coaches that the students said were helpful. We didn't give them to the coaches that just kind of checked out. But if the student team said, yes, this person helped us out, then we bought them a little token of appreciation. And so, just kind of maintaining friendly relations. And something that I read some time ago, and it sure seems to hold true, is the way to get people to be willing to do you a favor in the future is to get them to do you a favor in the past. It's not transactional where I do you a favor and you do me a favor. It's you do me a favor and you feel invested in the successes, and so you're more willing to do a favor in the future. So just kind of getting them started the first time, and then showing the appreciation for it, kind of really helps the future favors.
Sort of related. Do you have a business school? Have you drawn upon people from there for your market analysis type stuff, or talking about
Yes, we have a very big business school. A few years ago, they built this huge, really ugly building, but they didn't ask for my input on how it looked. But yes, they do have a business school, and in the interest of not drawing in too much university support, we didn't ask them to provide that the training that Don't Panic Labs was willing to provide. One of the things we did consider was having our students take some entrepreneurial classes, but our students in the software engineering major have no flexibility for free electives. They have, it's very rigid to the point that the university is looking at requiring everyone to take some other course, and we're scratching our heads trying to figure out how it's going to fit in without adding more credits to the major. So requiring students to take our software engineering students to take entrepreneurial classes as a 4-credit thing really seemed like it's something we would want to try to avoid if we could.
Thank you.
Mm-hmm.
I have a question for Emily. If I understand correctly, the evaluation that you were doing of students was after the simulation game. I'm wondering if you have done any study yet of students as they transition from the game into actually doing, Scrum for software development, and the degree to which those understandings transfer well, into the actual practice of doing software.
Yeah, we haven't done any studies specifically related to this simulation, but we have actually done another study on soft skills in these courses that we will use the simulation for. And that's going to be published here in the International Conference for Global Software Engineering next week. So yeah, we do have a few results from that. The main learning outcomes there were definitely, they were quite similar, related to communication, interacting with a product owner, and agile coaches from the industry. So the collaboration with the industry was a big part of the learning.
Other questions? Chris, I guess I have a question for you. Given that you're using a startup model, startups fail,
Mm-hmm.
and so how do you build in to make this a sort of authentic, kind of startup experience? The likelihood that they're actually going to make it is quite low. How do you, get that idea across, and also evaluate the students, saying, hey, good job, it didn't work, but you did everything right, or that kind of thing.
Well, of course, that's one of the things you have to do is make failure okay, because you learn a lot from failure. And so that first group, one of the reasons why they did take most of the semester to get through their market analysis was because they kept discovering they needed to refine and redefine the product that they were going to be working on. So in that regard, it's baked right in. And then beyond that, did they learn what we expected them to learn as far as being the kind of the business side of starting something up? and then did they work faithfully toward doing that? And that first group was came up with a beta product by the end of that first year. And just from a timing perspective, there really wasn't much more we could have expected. As far as failure or not, well, the LLC still exists, but I haven't seen anything come out of them since that beta product. On the other hand, the team that this last year's team, so the one before did something that was kind of an event, not exactly planner, but and it was not exactly a traditional product. This last year's group, they did a game, and so their market analysis was toward figuring out what kind of game the market wanted. They already have a publisher talking to them about putting it out on the broader market once they finish it. They already have their demo out, and that got the publisher's interest. So,
Great. Right. Other questions from the audience? Okay, well, I think we can wrap things up then. Thanks very much, everyone, for the great presentations and the great questions too from the audience. Good discussion, and good. Hope you all have a great weekend.
Take care.
Okay, thanks. Bye bye now.